Ladies and gents, hope everyone's doing well. This is 3.4, Expanding Quadratics, aka Foiling. The letters F-O-I-L are capitalized because they're going to each stand for something that we'll get into. But I think the word foiling is really funny because it sounds like, you've prevented someone from getting away from something. So if you think of a person standing there, hand shaking in the fist, you foiled me, The other way you can think of it is if you're like wrapping a person in tinfoil, which is kind of weird, but whatever you want to do, you do that. This is the third lesson in the quadratic section, and it is March 27th, as always. Mr. Benjamin here. I hope you'll be able to learn something from this video. Learning goals for this video: expand and simplify equations. We use the words expand and simplify a lot in mathematics. Another way of saying it is solve or distribute. We're also going to keep in mind collecting like terms. These things will come up in this lesson. The whole FOIL concept. Okay, so FOIL stands for first, outside, inside, and last. And that will make sense once we get into the actual material. Finally, we're going to convert quadratics from factored into standard form. And we will recall what those look like on this slide. So, if we recall quadratics, what is a quadratic? A quadratic is a relationship that's always to the second degree. What that means is the first differences will be different, but the second differences will be the same. So I'll write different up here. Diff. And because of that, we end up with a nonlinear relationship. Remember, linear relationships will be straight lines. Doesn't matter what direction they're in or to what angle they are. But quadratics will always have a U shape, whether that U is upside down or right side up, or we say opens up and opens down. So I'm going to write opens up. This one is opens. Oh, that one's still up, actually. The blue one over here at the bottom opens down. We can associate positive and negative with these images as well. So any graph that opens up is going to be positive, just like a happy face. And any graph that opens downward is going to be negative, kind of like a sad face. Don't always want to make that association between sadness and negativity, but sometimes negative things make us sad, right? Standard form for these equations: y is equal to ax squared plus bx plus c. The factored form: y is equal to a multiplied by x subtract s, both in brackets, and x subtract t. Now these variables can be anything. You can change them around, doesn't really matter. I think the textbook uses r instead of t. I have no idea why I'm using t. I think I like drawing t's like that, so I like using that. From the factored form, we can easily find our zeros. And zeros are very important. For zeros, we set y to 0. So in this case, it would be 0 is equal to x minus s, and 0 is equal to x subtract t, right? And what are those zeros? Those zeros can take place in 3 different places, or in 3 different situations. This first graph has 2 zeros. This second graph has 1 0. And this last graph has no zeros. I'll just write no zeros. This is a bit of a mess now, so I'm going to go to the next slide. We're going to look at expanding and simplifying. Like we said, this could also be called solving or distributing. Now that's specifically distributing, for these examples. Now how we do that is we take this 6, and we know anytime we have a 6 with a bracket anything, so 6 bracket a, that's going to equal 6 multiplied by a, which will equal 6a. Now inside of this bracket, we also have negative 8. So it's the same as saying 6 multiplied by negative 8, which would equal negative 48. So in total, the way we look at this is this 6 is multiplied there, and that same 6 is also multiplied there. So we'd have 6a subtract 48, and that's our answer. We can't take this any further unless we know what a is. So that's our final answer. The second equation has multiple terms. There's 3 terms in here. This 2 is going to distribute towards all of them. So 2 multiplied by 3, p. 2 multiplied by negative 7, k. And 2 multiplied by 4. So we'll have 6p subtract 14k plus 8. And because we don't know what p and k are, they are unknowns, that's as far as we can take that equation. This last equation, we've got r here, r squared here, g, and 1. So we're going to take this 10r, multiply it, multiply it, multiply it. So 10r multiplied by 2r squared is going to give us 20r cubed. And by the way, I should have equal signs everywhere here, so I'm going to draw those in. Equals. Then we've got negative 50 gr or rg. That would be the same thing, and that's our second multiplication. And then we have 10r multiplied by this positive 1, so plus 10r. Again, because we don't know what r and g are, this is as far as we can take this level or this question for expanding and simplifying. In many cases, you're going to have situations where you've got 2 sets of brackets. So for example, our factored form of our quadratic equation is y equals a multiplied by x minus r, x minus s, or t, or z, or q, whatever variables you want there, doesn't matter. In this case, when you're expanding, you need to expand, or you need to multiply each value by each value within the brackets. This is where foiling comes into place. So first, outside, inside, and last. I should probably do a better job of color coding this, so let me rewrite this and draw some arrows so it makes a bit more sense. Get rid of these. So that was x multiplied, or x plus 4, x plus 3. So first I'll do in whites. This means both first digits in the equation. So these two r's multiplied by each other, that's going to equal x, or did I say r's? X's. These two x's multiplied by each other, that's going to give us x squared, right? The outside terms. So that's going to be this x multiplied by that 3. And that's both positive, so it's going to be 3x. I stands for inside. The inside terms. Now those are the 2 in the middle. These ones are already yellow, so it's going to be pretty easy. This 4 multiplied by this x. That's going to give me positive 4x. And finally, we have the last 2 terms in the equation. Multiply those together. So it's positive 4 and positive 3, so that gives me positive 12. Now, again, that looks like a disaster right there, but we're going to do more examples and it's going to make more sense. When we look at this equation now, we can say that's our final answer, but that's not true. The reason for that is we have 2 like terms. We have x squared, and that's the only x squared or second degree unknown, but we also have 3x, 4x, and just 12 on its own. So these 2 can be added together. We can collect our like terms and add them. So that's going to equal x squared plus 7x plus 12. And there is our final answer for that first question. Moving on to the second example. This 2 is a bit too close for my liking, so I'm going to redraw that. Right there. We have 2x subtract 5 multiplied by 7x plus 6y. We're going to look at the first digits. So that's 2x and 7x. So 2x multiplied by 7x should give us 14x squared. we're going to look at the outside digits. So that's the 2 and the 6. So that 2 multiplied by that 6 gives us 12, and they're both positive. And x multiplied by y gives us xy. We're going to look at now the inside values. That's these two in the middle. So negative 5 multiplied by 7 is negative 35. We also have x and y, so x and y both need to be there. And finally, we're going to look at the last, which are those two digits there. Now they're both y, so I'm going to have y squared, and one of them is positive, one of them is negative, so it's going to be a negative. 6 multiplied by 5 is 30, so it's going to be 30y squared. Now again, we can look at this question or this equation and say, yep, that's our final answer because we don't know the variables, but we can put these like terms together. So positive 12 and negative 35. 14x squared remains the same. If I have negative 35 and positive 12, that should be negative 23 together. So subtract 23, xy, and then that negative 30y squared is still there because I can't change it. So that's our final answer for that equation. Going into the next example, this one's unique because it's a difference of squares, and I'll explain that in a bit. So let's do the first, x squared. Let's do the outside, plus 7x. Do the inside, subtract 7x, and the last digits. Sorry, I think I messed this up. Give me a second, let me just look at it. Yeah, I just drew that line incorrectly, so the last digits are going to be here, so it's minus 49. Now I can look at this, and I can add these two like terms together, and that, of course, gives me 0. Positive 7x, negative 7x. So x squared subtract 49. This is called the difference of squares. And that as well will come up in the future, but basically 7 squared is equal to 49. Let's keep that in mind for something like that in the future. This last example, we have 4x subtract 3 squared. So if we write that out again, it would be 4x subtract 3 multiplied by 4x subtract 3. And we do the exact same FOILing process. First, it's equal to 16x squared. Outside, subtract 12x. Inside, subtract 12x. And last, this will be plus 9, I believe. 3 and 3 negative, positive, yep, plus 9. So that leaves us with 16x, whoops, can't draw that up there. X squared, I have negative 12x and negative 12x. Together that gives us negative 24x plus 9. And that's our last example. So in many situations, we're going to be asked to change from factored form to standard form. So if we use this example here, we're going to keep in mind that standard form looks like this. Y is equal to ax squared plus bx plus c. And factored form looks like this. Y is equal to a bracket x minus s bracket x minus t or r or any other variable. I'm sure there is a reason for that, but don't worry about it for now. What do we have right now? This, to me, looks a lot more like that than it does to this. So we're going to be changing from factored to standard form. How are we going to go about doing that? Well, the first thing we can do in this situation is find our zeros. Keep in mind, zeros is when y is equal to 0. So if I set this equation up, 2x squared minus 7 is equal to 0. If I rearrange this, I'll end up with 2x squared equaling 7. X squared is equal to 3.5. And if I root 3.5, x is equal to 1.81 approximately. Now, let me redraw that. Now, it's not positive and negative, or it's not positive or negative, because anytime we square a number, say we square negative 5, that's going to give us 25. if we square positive 5, that still gives us 25. So we don't know if these zeros are positive or negative. So in fact, what we say is x is equal to negative 1.81, and x is also equal to positive 1.81. So in our grid, that's negative 1.8, and that's positive 1.81. We know that those are our zeros, and our parabola is probably going to look something like that. Unless it opens up, it'll look something like that, but we don't know that yet. All we know is what our zeros are. Okay, now that we found our zeros, we can look at finding our midpoint. Midpoint between the two of them is actually kind of irrelevant at this point. Actually, all we really need is our y-intercept. Well, really, we can't find our midpoint. Do it really quickly. Remember, that's the area in between the zeros. And we do that by finding the average, so 1.81 plus negative 1.81. Of course, that will equal 0, so it'll be 0 over 2, which is 0. Okay, so again, if we draw out our little grid, 1.81, 1.81, midpoint is 0. What information that gives us? That will tell us where our vertex is. Since our vertex is going to be the same as our y-intercept, all we're going to do is find our y-intercept. Actually, I'm going to give myself a bit more room here. Get rid of all that jazz. So I'll do y-intercept. For a y-intercept, we set 0, or set x to be 0. We know our equation, excuse me, y is equal to 3 bracket 2x squared minus 7. So if we sub in 0, we get 3 multiplied by 0 subtract 7, and that's going to give us negative 21. I'll draw that out again. So we know our vertex is at 0 and negative 21. We know our zeros are at negative 1.8 and positive 1.8. If we'll say this is negative 21 down here. So our graph is going to look something like this. There you go. The last thing we'll do is find our a value. All you'd have to do there is sub in the vertex point for x and y. And solve. I'm not going to do that because I've ran out of space and I've already written out this question, but I can do that again in a later video. So let me star that here. I'm going to try the second example. We're going to start off the same way as the first one by finding zeros. Also already at 18.5 minutes, so I kind of want to keep this a bit shorter. 3p equaling 0, p equals 0, so one of our zeros is 0. And then we'll also have p subtract 9 equaling 0, so p will equal 9. So we know our two zeros, so if we were to draw our grid over here, one is at 0, one is at 9. Keep that there for now, I guess. Might get rid of it later. Find our y-intercept. Sub x equals 0. Y is equal to 3p multiplied by p subtract 9. 3, 0. Well, this whole thing's going to be 0. If we work this out, 0 subtract 9, it's going to be 0 multiplied by negative 9. So our y-intercept also equals 0. So this is going to be interesting. We're going to look at our max and min at this point. Find that value, we're going to have to find our midpoint first. Midpoint, that looks nothing like midpoint, sorry. Which is also called the axis of symmetry. So we're going to take our two zeros, 9 plus 0, divide that by 2. So x will be equal to 4.5. So that midpoint value is going to be right here. Whether it opens up or down, y-intercept is 0. Well, let's find out. Let's try to find our max value. Slash min value, slash optimal, slash vertex, whatever you want to call it at this point, all will be accurate. And we sub in midpoint for x. So our equation was y is equal to 3, well in this case it's p, sorry, not x. I'll write this whole thing in red. Y is equal to 3p multiplied by p subtract 9. It's equal to 3 multiplied by, what do we say, 4.5? Multiplied by 4.5 subtract 9, which will be negative 4.5. So 3 multiplied by 4.5. Negative 4.5 is going to be a big number. I'm going to have to grab my calculator for this. Give me a second. I've got negative 60.75. Someone can correct me if I'm wrong, but we know that means our vertex is at, and I'm sorry if this is blocked off by the little hand there, the Dockery hand, 4.5 and negative 60. I'll just put 61 for ease. So that's going to be somewhere over here. Let's call that negative 61. I'm going to get rid of this vertex. I'm going to get rid of the vertex to write in the vertex. That seems pretty accurate. Let's draw this in yellow. There you go. This opens up, so it's positive, which means we have a negative value for our minimum, which makes sense. All good. We can have word problems. We can have diagram problems. This one's pretty straightforward. I mean, it does require some work, but knowing that a parabola, so you know it's going to be either opening up or opening down, second degree, has zeros at 6 and negative 2, and an optimal value of 8. What is the equation in standard form? Okay, so we know our zeros. Our 6, 0, and negative 2, 0. For that, we're going to find the midpoint. Which will be 6 subtract 2 over 3. Is equal to, oh, not over 3, sorry. Over 2, which is equal to 4 over 2, which is equal to just 2. So if I draw a quick grid here, my zeros were 6 and negative 2. My midpoint is 2. My max and min will come from that value, but we know that it's an optimal value of 8. So it's my max. So that's going to be here somewhere. So that's what my graph's going to look like. It's not bad for freehand. I'm usually really bad at those. We have to find the equation in standard form. So that is y is equal to ax squared plus bx plus c. What information do we have at this point? We have zeros, we have optimal value, I think we have enough. We're going to have to find a, so that means we're going to have to use factored form first. Factored form is y is equal to a multiplied by x minus s, x minus t. We're going to put in our zeros, okay? When we put in our zeros, we always change. Zeros were 6, negative 2. We always change the operation in front of them. So if it's positive, it becomes negative. If it's negative, it becomes positive. Because in the standard form equation, it is negative. So we have to flip the equation. So y is equal to a bracket x minus 6 and x plus 2. Okay? Clear with me so far? We know the midpoint is, what did we say it was? 2. And the optimal value is 8. So we know that point, 2, 8. So what we're going to do is we're going to sub that into here. And I'm actually going to go to the next slide. But I will copy all of this. Getting really long now. We're into the 25-minute mark, and I apologize for that. So if we do 8 is equal to a bracket x. Oops, don't need the x anymore. 2 subtract 6, 2 plus 2. It should all work out, no problem. Of course, whenever I say that, it means it's probably not going to work out. Negative 4, and this is 4. So 8 is equal to a, so by negative 16. If I divided both sides by negative 16, a is equal to negative 0.5. So now I know that my equation in factored form is y is equal to negative 0.5 multiplied by x subtract 6 and x plus 2. So keep in mind, this is factored. We don't want factored form, we want standard form. So the way we're going to work this out is just like we did before. We're going to take these values here and we're going to FOIL them. FOIL that. What does that leave us with? Y is equal to negative 0.5 multiplied by x squared. That's first. Now we're going to do the outside, plus 2x. Inside, subtract x, or 6x. And last, subtract 12. Let me rewrite that because that's way too small. It'll give me more practice on doing it too. Negative 0.5 multiplied by x squared plus 2x, subtract 6x, subtract 12. Okay. Now I have to distribute my 0.5, or my half if you want to say it that way. It's equal to negative 0.5x squared, subtract x. Subtract x or 2x? What am I looking at? Oh, made a mistake first. Sorry about that. I have these two like terms. I have to add them together. So y is equal to negative 0.5 multiplied by x squared. Subtract 4x, subtract 12. So now I can distribute. Y is equal to negative 0.5 x squared plus 2x, because that negative and that negative give me a positive, and also plus 6, because that negative and that negative give me a positive as well. And I believe that looks like my y is equal to ax squared plus bx plus c. So there's my equation in standard form. All right, 28 minutes. Thank you. Happy face. Have a great day. Have a great weekend, whatever day it is. Have a good one.